more about the thinking process of an employee, how we can measure it in terms of efficiency of an employee. And the research gap we found out of these studies when we are seeing that is there any connect actually circular economy concept to the employee perspective. Yes, we found that the district studies with HRM concept that how it can support the integrate the sustainable performance of an employee integrate the circular economy. Then we found a research gap that what kind of a relationship between an employee performance to the sustainable outcome, and also the adoption of the green circular economy to the organization perspective, and also the metrics how we can measure to give a quantitative measures for the employee performance. And the aim or objectives of our study is to overall to identify what kind of capabilities we can see the normal circular economy concept reuse of wastage of resources, material and all. In perspective, in related to employee that what sort of capabilities we can measure and we can take in consideration of the circular economy, and based upon that what kind of metrics we can evaluate to increase the outcome of a organization. And for these two methods, that the evaluating factors we have studied is narrative literature and also model and based on the bibliometric analysis. And the model why we have taken dynamic capability model. Business environment businesses these days we can see that if at all they have to be in the longevity of the business we can so they need to be a dynamic. So the dynamism we can be talking about the organization need to concentrate more on opportunities and also the competitiveness is important. So that is a strong criteria we have taken by adopting this particular model, where the strong capabilities, as I mentioned, the capabilities from the literature review. We identified and incorporated this particular model also in our study. So these concepts which we identified through the literature review in relating to the employee and also sustainable outcome is innovation, technology, and culture. And these are the studies. In relating to innovation, green innovations, innovative culture, and marketability of innovation. And this is one of the metrics organization can concentrate if they wanted to make any innovations in the organization. Similarly, the technology, the new technologies, green technologies, an organization can adopt. That also one of the capabilities, strong capability, is helpful for the organization. And culture, yes, culture is an important factor which any change if you wanted to make, resistance of an employee is also equally important. So green culture and green competencies of organization can develop. That will also enhance the outcome of an organization. The recruitment is another strong capabilities where these days organizations are thinking about the green jobs. For recruiting an employee, the talent acquisition, what we talk about, the employees green job descriptions and all people are having, or employees or prospective employees, whomever is applying, they should have a green thinking of sustainable practices, such kind of an employment they are giving. And similarly, leadership and strategy also. Whatever changes we wanted to adopt in the organization, top management need to adopt that particular strategy in the organization. So strategic leadership also plays an important role in the organization. Finally, with all these attributes which we have taken from the literature review, supporting to the conceptual model for the sustainable outcome of the organization. And for this, we use the bibliometric analysis, where co-author analysis and co-author analysis when we have done. These attributes or the capabilities what we have taken is completely picturized in the form of a graphical presentation, where these components of the 6 what we have taken for this study out of the literature since from 2005 to 2023. Yes, these factors are completely impacting the sustainable outcome of an organization. And the findings of this particular study means the various authors so far have studied individual areas like culture, technology, recruitment, strategy, and all. All these are definitely impacting the sustainable outcome. So with this paper, we just wanted to convey that organizations can also improve the sustainable outcome of performance of an organization. Employee perspective also make them certain concept of thinking process of an employee, develop a circular skills among the employee, the sustainable performance of the organization. Thank you. Coming next slide. Yes. And just so these are the capabilities we have taken: innovation, technology, recruitment, learning and development strategy and leadership. And this is a bibliometric search criteria we have taken for the literature review. And this is the keywords we use: circular economy, waste management, sustainability, skill or knowledge. And the only database we have taken for our study is Web of Science only. And total we got 1,000 odd. From that we have an exclusive criteria of this exclusively the business related parameters. And finally we did for this presentation we did only co-occurrence analysis and citation publications. And these were the number of publications from 2005 to 2020. 132 after incorporating the individual criteria, and these are the citations of the papers. And this is the network visualization, as I mentioned, the sustainability innovation strategies and culture and green HR. So there is a connect between the circular thinking in the organization. We can adopt, make an employee to upskill themselves to the circular thinking process. Definitely there are chances to get the sustainable performance in the organization. And these are the findings of the study: yes, green performance indicators, green technologies, green workplace cultures, and new business models also if they can concentrate on green transformational leadership. All these things will definitely help for the organization to enhance the sustainable performance in the organization.
Circular economy. Let's say circular economy is a resource regenerative model which include the materials which are existing can be reintroduced in the market so that we can conserve our resources. So before going to the complete introduction about circular economy, let us know about how this circular economy came into existence. Okay, once upon a time, after the industrialization happened, then the linear economy model used to came into existence. Like we used to take, make, and use and waste. Simply, we used to take out the resources. We manufacture it, we use it, and we dump it. Simple. So after that, people came to know that okay, this is going to be a big problem. So what can we do? So then recycling economy came into the picture, and then people are going to do some kind of recycling to the materials, but still some of the waste has been handed up. So because there is no proper protocol how to streamline the recycling process and all. That's how circular economy came into the picture. And we have introduced some of the arts which are recycle, reuse, remanufacture, those kind of things comes into the picture. And then with this circular economy model, they have aimed to zero waste, and it's been achieved with the help of circular economy. Let us so the significance of the research which I have going to present is like the need of the technology adoption. We will get to know, and the research will extend the knowledge gap between the technology with industries, and it also addresses the knowledge gap existing in between technology and circular economy. And with the rapid increase of the population in India, we have to know that with population increases, the consumption pattern has been increased. This could become a possible threat to India, or whatever the country is, it could be a possible threat. So what the same model, the linear economy came into existence, and they have identified the threat, and slowly the developing economics came, and then circular economy has been introduced as a resource regenerative model. And then with circular economy, energy leakage can be minimized, and it can be used to close the material loops so that in future the resources can be preserved. And over the past 10 years, the circular economy in technology has been rapidly increased, as we all hardly ability. Let's say we know that the technology adoption has been increased drastically. The same technology has been implemented in the industries, so that by linking the circular economy technology available technologies, so that it can be make our life easy. So that there are a lot of changes going to be happening with the adoption of technology. Yeah, okay. So these are the research questions which I have was aiming to, and so what are the digital technologies available in the field of study, and what are the roles of technologies that can contribute. Like there are the different types of technologies and what exactly they are contributing to circular economy. And how are these technologies can help the manufacturing industries, small, big, micro, whatever it is, how they can help. So I have adopted SLR methodology in order to take out the information from the different articles which are already published. With those, I have taken Atlas, which is a qualitative coding software, so that I can finally landed up in set concepts which can streamline the entire business. So I have adopted SLR technique, which I have come up with a different kind of keywords, which landed up like 57,821 by using necessary filters, necessary abstract filtrations and all, and taking out the technology aspects. Finally, I have landed up with 156 articles. Upon these 156 articles, the entire research was based upon. So some of the findings which I have came into existence like XR, extended reality, which can help to take action in response. Which this technology can help industries like visual reality, augmented reality, artificial intelligence, blockchain, IoT, big data and mixed technologies. These all technologies all together can contribute in tracking, identifying the resource usage. For example, you have bought too many clothes, and if there is any RFID tag existing in it, with these technologies we can identify that okay, some ex-person have bought all these things but it's not yet used. What can we do with that? We can recollect, we can reintroduce it in the market. So that's how these things can help small industries or medium industries can track how the technology and how the usage can be done. Yeah, with the findings, I have come up with the conceptual framework which how the technology can be adopted in order to manufacturing industries. Like some of the drivers that came up with investments. Investments are needed, government support is needed, innovations, innovators, and knowledge sharing is needed. So these would be a possible drivers for adoption of circular economy. And the second stage is SMEs, companies, societies, and technology providers, customers, like big data analysis, like those are the providers. So with these providing stakeholders can be acting as stakeholders, and the different technology which I have identified could be triggers, possible triggers. And then with the actions and outcomes, the economic, environmental, and political aspects, these are the performance can be achieved. So this is the final contribution which our aim is to how to contribute technologies in order to achieve circular economy technologies, right? So these are the different technologies which I came up with that 156 paper. Okay, based on that 156 paper, this model has been generated. And with the different technologies, we can achieve different contributions. I have collaborated everything into like all technologies all together, and then the final model can be achieved. So like this, I have come up with a particular framework which can be applicable in the normal industries, so that they can achieve the zero waste, or they can achieve reverse logistics or recycling kind of aspects can be achieved with this model. It is yet to test. And some of the challenges based upon 106 researchers. So possible challenges would be ambitious promises, like promising everything, but cost is a main aspect. And organizational culture shift, like some new technologies coming. Obviously, we know the technology is kind of costly. So who knows? So some of the industries are not yet ready. Shift their organizations and collaborative culture, because if you are collaborating, for example, one company with another company, be a possible competitor, why you will collaborate with your competitor? So that could be a possible threat. And some of the people misuse of information, even though I have some exclusive information I am sharing it to the online. Who knows? Somebody can take it and copy it and do the prototype kind of thing. It could be a possible threat to me. So that those kind of things can happen. And data security misuse, resistance to change. For example, human behavior. Why should I change? I am in possible condition, comfort zone, and I am getting almost everything nicely. And why should I change? Why should I adapt the new change? So those kind of things are the challenges which I come across. So with this, I would like to summarize this technology adoption can create new sources of revenue, and this technology adoption can make a human industry owners or in their behavior pattern, which they will see the waste as a possible value stream, so that they can adopt and change. And also with the blockchain, circulation task, identifying, monitoring, this can be happened. With the IoT, larger scale marketplace to be developed, And Industry 4.0, as you all aware of it, to extend the technologies of Industry 4.0, it can be like conclusion, like I'm going to conclude about the highlighted things are the main aspects of circular economy, like adopting. Once we integrate the circular economy and existing technologies, can give the possible outcomes. So some of the references, and thank you.
Afternoon, everyone. I'm Riya Sharma, research scholar from IT Delhi. So today I'm going to discuss one of our research findings under Going Global Partnership Industry Academia Collaborative Grant funded by British Council. So I am fortunate, I have got an opportunity to present our work on the strategy to reduce the environmental and health impact of domestic cooking application by replacing traditional cooking stock with ideally developed improved stock. So as we already know, air pollution has become a critical issue being faced by mankind today. In India, around 94% of the population live in the location where air quality exceeds Indian air quality standard. The pollutant concentration in rural areas is 5 to 6 times higher than that of urban areas. So here I am going to discuss two major sources in the rural part of the country. The first one is traditional cooking and the second one is stubble burning. So as we know, in India, around 70% of Indian households still rely on traditional cook stove for their food. And the fuel used in traditional cooking stove is made up of a moist combination of dung, dry wood and wood chips. When the people burn this fuel in a chula, it will give 5 times more pollutants than the coal. And according to the one study, it is found that chula is responsible for more than 25% of the death in the country. We will talk about the stubble burning. Stubble burning is a very common and cheaper process in the rural part of the country. Mostly in winter season, lots of the stubble is burned in the field as people want to prepare the field for next crop, which is contributing more than 7% of total particulate matter emission. Not only particulate matter emission, but huge amount of energy is wasted, which adds to the global warming. Here we can see the Indian scenario. In 2019, air pollution was responsible for more than 1.6 million deaths, out of which 70% of the death happening due to non-urban activity. So the main focus of our research is to transforming the traditionally agriculture practice, stubble burning, into a possible solution. So instead of letting stubble burn and contributing to the environment, we are utilizing it to generate energy. This strategy is win-win and it helps the environment by reducing the pollution level and assess the health impact due to lower air quality. Moreover, replacing traditional cooking stove with improved cooking stove, we are ensuring high efficiency and better health while further reducing the environmental pollution. So this project is about an innovation and sustainability. It is not just solving one problem, but it's creating multiple impact on both environment and health. So the objective of this study was to find out, observe and understand the major problem faced by the rural women, and then quantification of the health impact as before distributing the IPD developed to 40 households. Initial health data has been taken. Health parameter taken into consideration are lung function test, blood pressure, pulse meter, and height and weight. Health monitoring will be conducted after every 3 months. Then potential benefit of improved cooking stove will be measured, such as it reducing the cooking time, it reduces the fuel preparation and fuel collection time, and it reducing the environmental pollutants. And then customization of the cooking stove design on the basis of user feedback will be done. So these are the research activities. First, initial field survey has been conducted, in which study location and volunteers has been identified. Then initial hand monitoring is to be done, followed by cooking stove distribution, intervention of new strategy which can reduce the pollution level. Then indoor air quality monitoring has been done for a specific type of period, followed by user feedback collection and consumer testimony. So these are the activities which we did in the field. So coming to the participant testimonials, we have collected the user feedback. They are very satisfied since improved cooking stove consumes less time for the fuel for the food preparation. It's easy to operate and it emits less amount of pollutants. So here we can see one video. Here we can see one video in which user is sharing their personal opinion about the usage of improved. This is the Okay, like C is saying, I am very happy to use this improved cookie stove. I can save my time. I can use that time for my study purpose and for other work.
खाना बना लेते हैं, कभी खाना चाहिए होता तभी बना लेते हैं।
पुराने चूल्हे में खाना बनाने के बजाय इस चूल्हे में खाना बनाने में आपने क्या फर्क देखा?
इसमें खाने में अच्छा लगता है।
So coming to the result of discussion, we have compared the traditional cookie stove with IT developed cookie stove, and we found that there is a variable difference in the emission of particulate matter and carbon monoxide, and we can see the efficiency of IDT developed cookie stove is 4 times higher than that of traditional cookie stove. We also check the water boiling test, and we can see there is a constant time difference. On-site field monitoring is still going on. Here we can see some variable in the particulate matter concentration at traditional cookie stove due to IDT developed cookie stove and background connection level. So the overall strategy of this project to convert agriculture waste such as crop waste and other waste to processed fuel such as biomass pellet, and then biomass pellet can be used as a fuel in the improved cookie stove. So this strategy is about is a green strategy which are giving the solution of stubble burning. So coming to the conclusion, we can say improved cookie stove excel ease of their ease use and saving cooking time compared to traditional cookie stove. Utilizing of biomass pellet as a fuel offer a sustainable solution to reduce the stubble burning. Project success is evidenced by its high consumer demand, robust satisfaction metric, and positive interest to adopt improved cookie stove. At laboratory scale and field scale, initial assessment shows that improved cookie stove emit significant lower amount of pollutants compared to traditional stove. And the main thing, this project provide rural empowerment by giving them training in the field of pellet making industries. For that, recently we got top of grant from British Council. So this is all about my project.
Please take the online training. And in the chat you write for 8364 is the presenter and that's it. They will share this. Okay, now presentation is by Mohammed H.P. SME. He's from Tunisia. Is presenting characterization and techno-economic evaluation as pyrolysis into biofuels and biochar. Sir, please present.
Hello everyone, I'm Mohamed Isawi. I'm a postdoc in French. Today I will present my work during my PhD, named the Characterization and Techno-Economic Evaluation.
Present, sir.
What? Hello?
Okay, Mohammed,
Are you
for
hearing
us.
me?
Yes, we hear you, Mohammed. It's okay.
Okay. I need to start again, or I don't know. Okay. I will start again. Okay. Today I will present.
Can you please unmute yourself?
Hello. Today I will present my work on PhD during my PhD. Named Characterization and Techno-Economic Evaluation of Polypropylene pyrolysis into biofuels and biochars. This work was published in Sustainable Chemistry and Pharmacy in 2023. I will start by discussing the energetic and environmental context. During these final years, we discovered that the energetic problems caused by the conventional fuel excessive and consumption and the limited resource of oils cause environmental problems such as greenhouse gas production increasing and the global warming. Which for that we will thinking about renewable energy such as biomass, which is oldest form of renewable energy and was discussing that is one
Can
of
you
the,
speak something?
excuse me, there is problem or something like.
كمل عم كمل شو عم تقول كمل.
Now like that is good. Okay. One of the interesting biomass was the production was the olive oasis, or the olive oasis, which is concentrated generally in Mediterranean countries, and one of these countries is Tunisia, which is the world leader in the production of olive oil, and over 30% of its arable is devoted to the cultivation of olive, which generates huge quantities of weights up to 1.2 million tons per year. 680,000 tons of olive meal wastewater and 400,000 of olive pomace. This olive pomace was used generally for as fertilizer, animal feed, oil extraction, or olive meal wastewater as fertilizer directly without treatment. For the olive wood was directly used
Hello.
for combustion.
Hi, sir. Can you wait for a bit? We can't hear you from yeah, the speakers are not synced. So if you could wait for 2 minutes and start your presentation, that will be good.
My name I will start. My name is Mohamed Isawi. I'm postdoc in French. Today I will present my work during my PhD. Is characterization and techno-economic evaluation of olive pomace pyrolysis into biofuels and biochars. This work was published in Sustainable Chemistry and Pharmacy in 2023. I will start by talking about general of the inertic problems, which after the using of the excessive fuels and the limited resources of fuels, we generate a huge environmental problems such as greenhouse gases production and global warming. For that, we gives us to think about the renewable energy, and one of the renewable interesting energy, which is biomass, which is the oldest form of renewable energy and used as green alternative biofuels. One of the interesting biomass, which is the olive oasis, which is generally the olive oil, which is concentrated in the Mediterranean basins. Tunisia is the world leader in the production, and over 30% of its arable land is devoted to the cultivation of olive. This the production of olive oil generates huge quantities of wastes, up to 1.2 million tons per year. 680 tons for olive meal wastewater and 400,000 tons for olive pomace. For olive pomace, it's used generally as fertilizer, animal feed, and for oil extraction. And olive meal wastewater was used as fertilizer directly without treatment, and olive wood for direct combustion in chimneys and animal feed. These wastes are rich by oil, cellulose, nitrogen materials, and phenols, which cause series of environmental problems such as eutrophication of the aquatic system, reduction in the fertility of the soil, waterproofing of the soil, pollution of groundwater and drinking water, the release of unpleasant odors, and the production of CO2 by combustion. Generally, the biomass are rich by cellulose, hemicellulose, lignin, sugars, fats, proteins, which used in biorefinery in three different process: biochemical process, thermal process, chemical process, to produce chemicals, biofuels, and electricities. In this study, we are interested in thermochemical process and used pyrolysis as one of the interesting process for production of new biofuels. Our fixed base was used under nitrogen for different temperature from 500 to 700 degrees Celsius with the heating rate from 15 to 25 degrees Celsius. We used in the study different we did the effect of temperature and the effect of heating rate, and then we discovered that the optimum conditions was 600 degrees Celsius for produced bio-oils with the heating rate 15 degrees Celsius per minute. And as we see, the mass yield of volatiles increased above 600 degrees Celsius, which is attributed to the occurrence of secondary pyrolysis reaction. For the biochar, the mass yield decreased with temperature due to the formation of char and decomposition of lignin, and there is slight effects of heating rate on the product distribution. For as a result of bio-oil characterization, as we see, the effect of temperature increases the carbon content inside bio-oils and decrease the oxygen contents, and there is a slight effects of heating rate. This study that shows that the increasing of temperature favor the deoxygenation and improving of carbon content of bio-oils. These bio-oils were differently characterized by using it for fuel properties, and as shows us that flash point was 44 degrees Celsius. The high heating value was 17.8 megajoule per kilogram. The color was DIL 8 and have low ash 0.02, and acidity index was 0.71. The CMS results shows that the major components identified were acid by 80%, nitrogen compounds 7%, phenolic compounds 4%, and monoglyceride by 2%. The bio-oil generally, which is rich by oxygen and have a low heating high value, which is discovered its application as a liquid biofuels. And this fuel properties needs catalytic cracking and or esterification to remove oxygen and to restore the low calorific value and the high acidity, the low flash point. For the char characteristic show also the high carbon content around 80%, and that the carbon content increased with temperature, and slight effect in the of heating rate for carbon content. Referring to the IBE and EBC norms, the produced biochars contain high carbon, which is emphasized their use as fertilizer and for carbon sequestration. Time of characterization of biochar so that is rich by pores and have mineral, the presence of mineral and small particle size on the surface, which is confirmed the ICP analysis that the mineral that biochar are rich by minerals such as calcium and sodium, for potassium with 8 milligram per gram. This biochars emphasize in the use as amendment for poor and acidic soil and as adsorbents. This study was used also for economic analysis, and we studied the use of the olive wastes for industrial pyrolysis unit. They refer to Yahya et al. For which is published to Energies, choose palm as for industrial pyrolysis units. So, referring to its results, we used the same analysis. The initial cost of pyrolysis units was 10 tons per day capacity with $2 million, and the final, which is 100% owned capital financing, which is will be working for 312 days per year for 8 years, and the interest of our investment will be returned in 10%. The housing and insurance cost is 2%. The capacity of pyrolysis unit selected was 10 tons. The annual capacity was 3,120 tons per year. For total annual operating hours, 7,488 hours. The revenue for the generation from pyrolysis of 1 ton of olive pomace was $480 per ton. The cost of production per ton was $280, and the net saving per ton was $200. The payback period, 3 years of using the olive pomace as feedstock for this pyrolyzer was 3 years based on the assumption made in this analysis. Based on the experimental data, this techno-economic analysis affirmed the feasibility of pyrolysis of olive industry waste. Finally, we will finish by conclusion. The 600 degrees Celsius and the 15 degrees Celsius per minute are the optimum conditions for bio-oil production during olive pomace pyrolysis. The bio-oil producers needs post-treatment to improve its quality, high carbon content of produced by char, and their richness in mineral and their pore structure favors their use as biofertilizer and soil amendment. As a perspective, future studies should investigate on the application of biochar as fertilizer and study its effect on the soil properties and plants growth, continue to work on energy and economic profitability as well as the improvement of product quality by pyrolysis, improve and optimize energy efficiency due to the still high energy consumption of the reactor, and study the application of pyrolysis products in order to assess the possibility of marketing these different products with a view to moving to an ambitious scale. Thank you for attention.
حتى للآخر كان في des questions, tu vas les avoir.
Ok, oui, j'ai compris.
Just go in. The session is over.
My presentation is the number A122, but I can't present tomorrow, so I asked Professor Ghosh to do this in this session, and he said, okay. That's why I if it is possible to give my presentation now, is it okay? Can I start? Do you hear me?
Yes.
Yes. Okay. So I'm Aida Benassen Trabilsi. I'm Associate Professor in the Research and Technology Center of Energy. We are working in our research team on waste to energy technologies. And now in this presentation, I will give you some activity that we are doing in waste to energy sector. So my presentation will deal with improving solid waste management in Tunisia and the solution of the waste to energy as the sustainable way to reach this target. Tunisia, for all our colleagues from other countries, we are in the north of Africa. We are a small country situated on the Mediterranean coast of North Africa, and we are in the region of Maghreb. The surface, the area, we are not a big country. We are around 6,400 square kilometer with a population around 12 million people, and the large coastline on the Mediterranean Sea. We are not far from Europe. We are 1 hour from Europe, 2 hours from 1 hour from Italy, 2 hours from France, and we are 12 hours from New Delhi, India. Tunisia is a touristic destination. We are receiving a huge number of tourists. In 2019, we received 9 million tourists who visited our country. We have the desert in the south. We have many monuments such as the Roman amphitheater of El Jem. But Tunisia is also a big problem. We have a big problem of waste. And we are facing a serious degradation of our environment because we are changing our consumption behavior. We have already a poor system of waste management based mainly on landfilling, and we have a lack of citizen awareness. So we are in an alarming situation, and we have to face this situation, because we have another factor, because we also all landfills come to their end of life. In Tunisia, we are producing yearly around 2.5 million tons of municipal solid waste, with a ratio around a daily production around 0.8 for urban area, of course by 0.8 kilogram per person and per day. In rural area, we are producing around 0.2 kilogram per capita and per day. We have a growth rate around 2.5 per year, and of course, as in most of developing country, in Tunisia, our MSW are characterized by high moisture content. We have very humid waste, and a strong presence of organic matter. This is the main composition. As you can see, we have around 63% of organic matter in our solid waste. Also, which is interesting in this composition is that we have packaging waste composition rate around 20 or 24% of packaging waste as plastic or cardboard, paper in our pool of solid waste. So the solution is to implement what we call the circular economy, so we can reduce the environmental impact of waste. We can reduce the costs linked to management. We can promote the preservation of natural resources, and also we can create jobs, and we can drive innovation and entrepreneurship. In Tunisia, since the year 2000, we have many national recycling programs, mainly linked to packaging waste. We set this program ECOLEF, which is a public-private partnership system, and it aims to reduce the packaging waste in Tunisia. We have also other national program like EcoPile, Eco Battery, EcoZit, and EcoFilter. The main program which is successful in Tunisia is the recycling of PET bottles, and this recycling, we have a good market for the collection, and for the conversion of this PET bottles in new materials for industrial uses, like in textile, for microfiber, etc. But what we don't have yet in Tunisia is this sector of waste to energy, and of energetic valorization of waste. To do the energetic valorization of waste, we have a lot of technology, a lot of process, and a variety of products as biofuels. In our research team, we developed yet some technology, some prototypes. Here we have a prototype of biogas that we developed in our team to valorize agricultural residue, and we have also equipment to analyze the biogas and to characterize the production of biomethane in the term of quantity and quality. For the thermochemical options, we have three main thermochemical options: pyrolysis, gasification, and incineration. In our research team, we already developed a prototype of pyrolysis for the leather waste, the fleshing leather waste in the framework of a collaborative project with an industrial of leather in Tunisia. We also developed another prototype of pyrolysis. It's a small scale, but also it's mobile and low tech process, which is destinated to farmers and to small PME to valorize their agricultural residue. So what we are producing from pyrolysis is our vapors, and these vapors are condensed as bio oil, and as non-condensable phase is the syngas, and the remaining residue is the biochar. And we are in our team, we are producing all these fractions, and we are characterizing them deeply, and we are trying to apply these fractions in several use. For example, for biochar, we are applying it for the retention and the depollution of wastewater, industrial wastewater. For the bio oil, we are characterizing it in point of view of fuel properties to be used as fuel in transport engine. So the development of these new technologies and innovative products could be a source of employment and the creation of a job, but the implementation of these technology are not well developed in Tunisia. This is the product, the application. Also, we developed gasifier, a downdraft gasifier for biomass and for local waste, and we are producing mainly a syngas from this waste. This is our some results of the gasification of our local waste as sewage sludge, sawdust, wood sawdust, olive pomace, woody waste, and almond shell, palmitic fiber, and other many other types of waste that give us high amounts of syngas with the good content of dihydrogen and other light hydrocarbons. Our publication are in journal, impact journal, and we have many projects in this thematic of waste to energy. So as a conclusion, rather seeing waste as a problem and a burden, it could be seen as a valuable resource that can be managed to produce sustainable benefits and value-added products. And this could be reached using cost-effective and simple technologies to convert these wastes into resources, energy, and materials. And here we have shared some of our experience on waste to energy and waste to materials. The 13 past years we started since 2010, and we hope to support shift to circular economy and sustainable development in our country, Tunisia. And thank you for your attention.
Good morning, everyone. My name is Fedi. I am a master's student. Today I am going to share with you a groundbreaking study on the thermal conversion of rosemary waste into alternative biochar and how this process contributes to a circular economy. Starting with introduction of problematic rosemary, then rosemary waste, properties and uses, rosemary waste as a source of biochars, and finally conclusion. We will underline the global energy landscape dominated by fossil fuel, the main source of energy in the world, and the huge demand of energy. So we will introduce the new lignocellulosic biomass as a renewable and available eco-friendly alternative fuel. Sorry, I have a problem.
Please share your screen.
فادي خرجت راك عاود اعمل بارتاج.
هي دقيقة واحدة لحظة مدام.
الناس تستنى.
صباح
Switching to presentation.
صافا كبر في حط مود ديابوزيتيف. مود ديابوزيتيف حط.
مدام محطوطة راهي أنا جست ما نعرفش علاش ما تجيكمش.
باهي ما يصيرش. كمل.
باهي أوكي. Now we will focus on rosemary waste. Rosemary waste are one of the leading available and sustainable resource in the world. In 2004, there are 350 to 400 tons of rosemary have been produced. And the main countries which demand for rosemary production are Tunisia, Spain, Morocco, and Turkey, which are the primary production nations. And also there is another country like South Africa and Zimbabwe, which joined in the cultivation of aromatic and medicinal plants. Moving now to rosemary use and application. Different rosemary wastes are traditionally used in many sectors. Among these uses, starting with essential oil extraction, the waste from rosemary can be utilized for essential oil extraction, contributing to the production of aromatic oils with various industrial and medicinal applications. Second, animal feed additives. Rosemary waste can be processed into a nutritional additive for animal feeding, offering another natural source of antioxidant and other beneficial compounds. Third, renewable energy source. Rosemary waste has the potential to be used as a biomass feedstock for renewable energy production, contributing to a more sustainable and circular approach in the energy sector. Fourth uses biochar production. Recently, experimental work was conducted to study the conversion of rosemary waste to biochar, providing a sustainable and carbon-rich soil amendment that enhance soil fertility and carbon sequestration. Now, rosemary as a source of biofoods. Different analysis like proximate analysis and the results showed that rosemary waste contain high volatile matters, low content of moisture and ash, and FTER results contain very rich in aromatic, aliphatic, and oxygenated functional groups. Lignocellulosic biomass contains cellulose, hemicellulose, lignin. The major constituent of rosemary waste are cellulose, hemicellulose, and lignin. In addition, rosemary contains high volatile matters and low moisture contents. Those factors make rosemary waste as an excellent biomass resource for energy recovery. Moving now to rosemary biochar application. Biochar is the black solid remaining after biomass pyrolysis. It is porous and enriched with organic carbon. Biochar derived from pyrolysis of rosemary waste could be used as sorptive for water and nutriment. It is a sorbent to remove different types of organic and inorganic contaminants from aqueous solution. It's also as a soil amendment for carbon sequestration and soil fertility enhancement. Now moving to some biochar operational condition. Rosemary waste biochar. The temperature was 400 degrees Celsius. Absorption of rhodamine B. Main findings on 20 milligrams of rosemary waste. So, the adsorbent demonstrated a reasonable the removal of rate 99.01 second condition, rosemary leaves biochar period temperature 550 main the dyes are cadmium and methyl blue. Main findings: the removal efficiency of CD2 plus increased upon increasing the initial pH from 2.5 to 5.5, while decrease in trend was observed for the MB dye when the solution pH was increased from 2 to 10. The removal efficiency of CD2 plus and MB dyes increased by 70% and 20% when the rosemary waste dose increased from 0.5 to 2 grams and 0.5 to 1 grams respectively. Rosemary leaves biochar releases temperature 550 with methyl red. The highest methyl red removal capacity was achieved by the biochar prepared at 550 degrees and 3-hour heating time. The results suggest that rosemary derived biochar can be a valuable option for waste water treatment. For conclusion, rosemary were very rich in volatile matter. They present low content of moisture and ash to be suitable option for pyrolysis. These factors make rosemary waste attractive source of energy recovery. Biochar derived from the pyrolysis of rosemary waste are good biosorbent for removal different type of organic and inorganic contaminant for aqueous solution. Also, they are good for fertilizer. Thank you for attention.
To ask, like when you said, after all, study one, the simplest traditional style. Are you trying to bring to that sound yes, different processes?
No, actually, yeah, the business is totally good. Clean product is a pure using biomass factor. So that biomass pellet, we are converting the silver products, which are waste from waste or that is used for biomass pellet. And that biomass pellet we are using. So this one project. Another project we want to compare this project. So in that we can make biomass pellet goes out. Now we are that's yeah. So my problem is like how we sustain that thing.
And that's part of the project. You're doing the demonstrating that equals. So I'm going to prepare.
Now we're in the for 6 months. They are we have but to the what is now by the people to the so we are in will some that you have to make and they will make science. People will buy that. The tree is store within 5 to 7 days last time. So they are the being made all of the guys because of how for where they are coming. So other political money, so several grants from the parent.
To deliver the summary about the session, please sir.
From already process.
Wait, can I ask one question to Mohammed Nashri?
Are you there? Ask please
Please, Mohammed Hashmi is disconnected, but I can. I'm her supervisor. I can respond.
Okay.
So I mean, see when you talked about all the formats oil conversion, I mean, like waste conversion to reuse again. So, I mean, how far, I mean, the application has done in the field? I mean, we understood that you have done the experiment in the laboratory to analyze the waste. But what about the practical applications? Are you going to apply in a mass kind of conversion, or is it just what is the next steps?
Okay. What we have done in this work is first the experimental in lab.
That's correct.
So we have the mass balance. We have the yields of products, the characteristics, etc. And then we have done a technical economic study. So if we upscale to an industrial pyrolyzer, how the engine and the process costs, and which is the price of products. So we studied the scalability of the olive pomace pyrolysis. And we have done this technical economic evaluation based on another study done by other authors. So the price of the engine was calculated as in the market. The price of product, also the price of purchase in the market, etc. The next step is to implement an industrial pyrolyzer in some olive oil production factories.
Great, thank you.
Thank you very much.
Actually, the same question applies to Fedi.
Fedi? Okay, Fedi, he's here, yes. He's connected.
So, we are also asking him that what is the practical applicability of that?
Scalability.
Scalability.
Of the rosemary waste.
Yes, in the same. Fedi also is in our team, and he's starting his master training, and he started working on a typical biomass, local typical biomass. And the next step, of course, if this biomass have good potential to produce, here we are working only on biochar. And if this biochar has good properties as a fertilizer and as bioadsorbent, we can recommend this solution to farmers, to agriculture, to valorize their waste and to use the biofertilizer for their poor land. So it's in the same optic that we are trying with several types of waste, of organic waste, of local Tunisian waste. And then our next step is to propose these solutions to socioeconomic actors. It could be farmers, could be agro food industrial, it could be municipalities, etc.
Just to summarize the presentation we have about 6 presentations. The first one talking about the green metrics and how to use green metrics to evaluate the performance and sustainable outcomes. And then we had the second presentation talking about adoption of circular economy using technology. So where Kesh has identified several technologies and how these technologies can contribute in adopting circular economy. And then we had a presentation from Ms. Sharma from IIT Delhi, talking about strategies to reduce the environmental and health impact of domestic cooking. Then we had online presentations. The first one from Mohammed HB, talking about characterization and techno-economic evaluation of olive pomace pyrolysis into biofuels and biochars, followed by Dr. Ada Ben Hussain.
About waste to energy.
Talking about improving solid waste management in Tunisia. Waste to energy in a sustainable way. And then we had our final presentation by Eddie Bay, who is talking about thermal conversion of rosemary waste into alternative biochars. And that's us from technical section 2 on day 1 in room number 304. Thank you very much.
Thank you. Thanking all the participants who take part in this conference and share your valuable information with us. I hereby request all the online participants to open your camera for a photo record. Please.